Hi everyone, well welcome back. Hope you had a nice break and are ready to keep on going. We've just got 2 pure lessons to do before we can start looking at just doing some general practice for all of the topics that we've been doing for the mock. So starting off, we're going to do Radians today, but before we do, I've got a little starter about the train tracks. I just thought I'd feed back to you on the answers on that. Now the Suguru I was able to sort out without too much difficulty whatsoever, but as you can see I got in a bit of a pickle here. So it all came down on the fact that I needed 6 gaps, 6 of them filled in here, and I went down there by mistake. So this train, just to let you know, goes along here and then it needs to go all the way back to there before doing that, and that way I'm pretty sure it's all solved. Okay, time to carry on. Right, copy this problem down, pause the video, see what you can remember about radians. And we're going straight in with a thing like this, and I'm not going to tell you what the formula are you've got to remember because they're not in the formula booklet, and I think the best way is just to figure them out from first principles, because you know that the circumference of a circle is pi times the diameter, and you also know that the area is pi r squared. And there are a couple of shortcuts we can take, and there's reasons why we use radians, which all come about because of being able to cancel pi out. But rather than try to remember what those simplified formula are, it's probably best just to go with knowing those. The perimeter of the shaded region when we've got 0.8 radians. Now the thing you need to remember is that 2 pi is the same as 360 degrees, or the full circle. And you know that the arc is going to be a fraction of it. And what we would do if it was degrees is we would write this angle over 360. Now we could do the same idea. If we're going to go for this large arc here, we need the perimeter, so we are going to, the perimeter for A is going to be 2 plus 2 plus the big arc and plus the small arc. So as we're looking at circumference, we're thinking about the diameter, so the diameter is going to be double whatever the radius is, isn't it? So for the big arc, you're going to have the circumference, or the arc, sorry, is going to be 0.8 over 2 pi, because 2 pi is the whole circle, multiplied by the diameter. And the diameter for the big arc is going to be, well, that's going to be 5 radius for the for that. Double that makes 10, doesn't it, for the diameter? And then we can cancel that times pi, sorry, and then we can cancel that down. So the pi cancels, and then you end up halving the diameter, which is where you may remember that we had a formula for half times the diameter times the angle is what you can do with radians. But I think if you work it out for yourself, it works out better. So 0.8 times 5 equals 4 centimeters. Then we've got the small arc. You may want to pause the video and do that again now if you hadn't done it before. The small arc is still going to be 0.8 over 2 pi, and that's going to be multiplied by, well, the radius is 3, so the diameter is double 3, is 6 times pi. So again, you're going to lose the pi, you're always going to lose the pi, and you're going to halve the diameter to go back to the radius. So you can say that the length of an arc is going to be the angle times the radius, which makes it an awful lot simpler. 0.8 times 3 is 2.4 centimeters. So then if we add all of these up, 2 plus 2 plus 4 makes 8, plus 2.4 equals 10.4 centimeters for part A. you may want to pause the video again before having a crack at and have a crack at part B before I talk it through for you. So this is talking about changing the value of the angle so that this whole perimeter becomes 14. Now it doesn't matter what the angle is, you're always going to have 2 plus 2 out of there. So what it's really saying is big arc plus small arc has got to add up to make 14. Take the 4 is take those 4 there is 10 centimeters, isn't it? So what do we do for the big arc? Well, we've been talking about the fact that we're just multiplying the angle by the radius. So the radius for the big arc is 5. So if we call the angle x 5x plus 3x is making 10 centimeters. Because you've got the radius times the angle for the small arc as well. So that gives us 8x equals 10, and therefore the angle must be 10 over 8, which is 1.25 radians. How about if we were to move on to a couple of sort of area problems to do with radians. So pause the video and give it a thought. Now, for this one here, you could probably do that, unless you needed it in exact, you could do that in degrees if you wanted to, because you've got a radius there as well. So that's 4 centimeters, isn't it? So if that's 4 centimeters as well, what you're dealing with is an equilateral triangle, which means that'll be 60 degrees. Now 60 degrees in radians, what's that? Well, we know that 360 is 2 pi. So if you divide by 6, you get 2 over 6, or 1/3 of pi is 60 degrees. So that there would be 1/3 of pi. Now you've got 180 degrees there, haven't you? So 180 degrees is 1 pi. So you could say that this is going to be 2/3 of pi. Now the area of any circle is always going to be pi r squared, isn't it? So that means that we would have, but we don't want all of it, we want 2/3 out of 2 whole pi. So if you imagine you've got 2/3 of pi being divided by 2 pi, that's the proportion that you want, times pi r squared. Our r is going to be 4, isn't it? What's that going to give us? The pi's there are going to cancel out. A half of 2/3 is 1/3, so you're going to have 1/3 pi times 16, which we could call 16 over 3 pi centimeters squared. So that's if they ask you for your exact value. If they ask for 3 significant figures, then you've got to just pop it in the calculator. Now part B, you've just got to think about your basic little angle problems first of all. So pause the video if you have already and give it a go. But we've got an isosceles triangle there because they're all dealing with radiuses, and therefore I know that this here must also be 0.2 radians. And what we must have here is going to be, well, what would be 180 degrees, take that, but we've got to start thinking about 180 degrees being 1 pi, yeah, because it's half of a circle. So all I need to do for that is call that pi take 0.4. Now if that's pi take 0.4, that allows me to work out what I really want, which is that angle there. that angle there is going to be 180 degrees. Take that. Well, 180 degrees is pi. So that angle is going to equal pi take 0.4. Now what's that going to be? Well, when I take pi, that'd be nothing. But when I take negative 0.4, that means adding it. So 0.4 radians is that angle. Now, working out the area of that sector, all I need to say is I know that the area is going to be 0.4 out of my 2 pi times pi times the radius squared, which is 5. Now we can cancel that, which is why the formula really says all you've got to do is a half times the radius squared and a half of the angle times the radius squared. Right, anyway, so what's all of that going to be? Well, a half of 0.4 is 0.2 times 25, which is a fifth of 25, isn't it? Which is exactly 5 square centimeters. So that's the angle one. Now we're going to have one more look at a perimeter problem just to finish us off. Right, this is a sort of question they love to ask, so pause the video, take your time, and it's not that tricky. First of all, for 1 mark, you've got 180 degrees there, so the angle of COA, that bit there, is going to be pi take 2/3 of pi, isn't it? Because pi is 180 degrees. If you take 2/3 away from a whole, you get 1/3. So it's pi over 3. Now, finding the exact perimeter of the brooch, there's going to be a little bit more to do here. So we know that we've got the diameter, and then we've got the arc, and then we've got what I'm going to call x there. So let's just work it all out one bit at a time. The diameter is going to be 4 centimeters. The arc we can do the same way that we've been doing before. So the arc is going to be 2/3 of pi out of my whole circle times pi hang on, what have I done wrong there? I've got carried away, haven't I? No, I haven't, because you've got that pi in there. That's all okay. So we've got the diameter that we need, not the radius, so that'll be times by 4. Sort all of that out. That's going to give us 1/3 there, isn't it? The pi's cancelled, but we've still got a pi there. Pi times 4, so it's going to be 4/3 of pi. Now they want the exact value, so there's no point working out what 4/3 of pi is for the arc. We've also got the 4 centimeters there, and we need to work this out. Now I know if I just consider that triangle separately, I know that we've got radiuses there and there, so I know it's an isosceles triangle like that. I know that this is pi over 3, which is actually, oh, let's think about this. That's 120 degrees, isn't it? And that's 60 degrees, because 1/3 of pi is 60 degrees. So if that's 60 degrees and this is isosceles, then actually there's only one thing that it can all be, because those two are the same length. That also means that these two are going to be the same as each other, and they'll also be 60 degrees, or 1/3 of pi. So that means that we're actually dealing with a an equilateral triangle. So you end up with your whole perimeter is going to be 2 plus 4 plus 4/3 of pi, which is 6 plus 4/3 of pi centimeters. Now, if you did want to work this out, if it didn't happen to be such a nice value, then what you'd need to do is you'd need to use the cosine rule, because you've got one angle that you know with the two sides either side, and you could work that out through to that, and that would give you 2 centimeters. Right, so that is all that I'm going to show you for today. There are 3 questions on the Maths Genius sheet which you'll find attached on Class Chart I'd like to have a go at, and let me know how you get on with it. Really important to practice all those questions. Okay, cheerio everyone.